Hello, today we will continue where we left off, and where we left off was with this polygon running on a PlayStation Portable. Today we'll make it to a cube. So I have the code, and you have the code in the last video. It's a download link in the description. I also have the vertex cube from the OpenGL 1.2 tutorials or live coding I made. Wouldn't maybe call it tutorials, but I got that one. It displays a cube in OpenGL. And I got the PlayStation buttons. That's when we pressing buttons on the PlayStation and things happens, prints out. So that's from another video also. We got those two from those other videos, and now let's try to make a cube. So first we have to draw a polygon, and we need a cube. So let's go to the cube here and just steal everything. And here is why I'm not going to type it in like from memory, so to speak, or I'm going to get this wrong, right? If I try to draw this and type this in, I will get it wrong. I can explain it though again. So we have our cube, and we got the color, we got the vertex, we got the vertex, we got another vertex, and to those vertex we also have color. So one might be green and one might be, what colors do I have here really? One is red and two are blue in this example. So we got our vertices here, minus 0.5, minus 0.5 and minus 0.5 is probably the one in the corner, bottom corner. And then we have a color, so the first one should be black. And then we have the indexes, which really tells the vertices which order they should be used and drawn. And I will fix my camera. There we go. Am I in the middle? No. Doesn't matter. So indexes jumps around up here and tells which vertex it should be used. So first we're using 0, 1 and 2 to draw a polygon, and then we're using 2, 3 and 2 to draw next polygon. So now we need to start using this also. Let's get rid of the drawing. So where do we have the draw function? Here we got the vertex. That seems to be the vertexes, the polygon we were drawing last time. There we go, there we got the draw call. Okay, so we need to put in the vertexes here, and we need to put in the indexes. And let's see the colors. The colors was just mashed in as the first parameter, and we had the vertex. So we need to do that with this stuff, which will be super fun to combine these two, but I guess that's needed. Put it here, and yep, this is live coding, so it's going to be manual stuff here. Sorry for that. Or I'm not sorry for that, maybe you are. There we go, first color. Maybe we can copy paste this. We have our vertexes for our cube. Just copy and paste that in there, and then we need another format on the red, green and blue. Alpha first, and then we have red, green and blue, but in reversed order on PlayStation Portable, so that I filled in this was kind of useless, I just realized. So now we got the vertexes. Of course, I was saying, yeah, now we need the indexes. Yeah, I was out traveling, and that's why I kind of stopped recording a bit. So, indexes, and we need some sort of type for that. Index. What type should it be? Glue vertex 32-bit. Then I need to know this function. And since I do not know it, Let's find out information about, there we go, I got a reference for this stuff. Let's find the draw array, there we go. And that said absolutely nothing on type. Thank you. Thank you very much. So what do we have? We have vertex 32-bit float. Let me take a guess. It's called index. I really do not think that I have 32-bit. I believe it could be 16. Okay, so it complained. I guess I have duplicated things, conflicting types. I never deleted this stuff up here. Move away with that. Try to compile it. Well, we don't have a polygon at least. Missing braces around initialization. Okay. Yeah, we are. Oh, that would be annoying to add in. Alright. Anyhow, I hope your Christmas was good, and New Year also. And I hope that you coded some. There we go. And braces around, scalar initialization. This is normally the point where I like I stop the recording and I like redo it from the start. Maybe I can learn how to fast forward a bit in the edit. Missing braces here also, but we don't have a type here. I'm guessing it's an unsigned short. And then I don't need a struct. Really goes well today. I'm pretty sure it's an unsigned short. There we go. Okay, it didn't crash. I mean, that's positive. They didn't display anything either. So we're going to, sorry for scrolling around, we're going to add indexes where it's a 0 here. And then we need to know how many indexes. Before that was how many vertices we were going to draw out. So divided by 3 and you have number of polygons. So that was 1 polygon. But now we need to specify the indexes. The index is going to be indexing into the vertices. So how many of those do we have? So we have 6 sides on the cube and we have 2 polygons per side, so that'd be 12 then. 12 times 3, I guess it should be a 3 in there. Didn't crash, so that's positive. Didn't display anything, so that's negative. Could it be that, no, I'm guessing here. Could it be that we need to move this away from us? Do not remember if there's too many arguments to function. Yep, the normal OpenGL. Let's see if we have a translate here. Do we have that? We have a rotate. That's good enough for example. It specifies the X, Y, and Z. But here we got the type instead, so we need to provide it with a type. That's the name of it. SCE PSP F vector 3. And incompatible type. And I'm just guessing it takes an address. Okay, so far it hasn't. Ah, look. Now we have something. That's just took, I don't know, let's see. 12 minutes. Probably need to cut that down in the video somehow. So there we go. Now we're going to make it rotate so we can see it's a cube. And we're going to do that going to PSP buttons, and this program is also in another video and the source code will be down in the description. You just need to rip out things from that one. So we initialize everything, and what do we initialize? I guess that's just OpenGL initialize. Yeah, looks like it. So before we do that, let's set up our reading the controls from the PlayStation. Let's call it setup. PSP setup maybe. And let's move that in there. And then probably the initialize should be called initialize. It probably should be called initialize graphic or graphic setup or something, but whatever. And then we have this function here to read everything. That we're going to just call in GLUT in OpenGL. We have the GLUT keyboard function that you can provide a function pointer to. We don't have that here, so just gonna call our method, and we're gonna call it void keyboard, and it takes nothing. I was going to say it takes an unsigned char int, but that's in GLUT and OpenGL and not in PlayStation Portable, because we just specified our own here. So we need an SCE control data, and then we need to include control also. Let's do that there. The control needs to be included. So let's see what it does. It waits for blank, we don't need to do that. It displays a printout, we don't need to do that. It's clear buffer control peak buffer positive. And sends in that struct, and I don't know what the one is for. And I want the analog stick, so we can delete all of that and just fill in the analog, and then of course we need something to store the analog in. And let's type them up here somewhere. Or should we do it after the 3D graphics? So we have rotation around X, rotation around Y. Goes well today. There we go. Set it to 0. We go down to keyboard. And rotation X. We set it to controller LX, which is that one. That's the left right on the PlayStation Portable. And then we need the Y. And if I do not remember incorrectly, on the PlayStation Portable it goes from 0 to 255 or minus 128 to 128. I don't know which one. I'm just going to test and try and see how it works out. Just start with dividing by 125, and why not plus 108? Plus a half, I mean. Yeah, that didn't work very well. That should in that case be here. And that's, I'm guessing that these values are from minus 128 to 128, and I want the value from 0 to 1. So we're adding in 128 first, then divided by 256. So if it's minus from minus 128 to plus, then this will work. We will see. Maybe, maybe not. So let's try to rotate our cube. Let's try to rotate it after here. No, not there. Let's try to rotate it after translation. And I'm hoping it takes the same kind of... wait now. The rotation... that's interesting. So we have something here. We have the cube again. I should leave the cube up. I seem to draw it all the time. Wonderful cube. And we have the different axes on the local coordinate system on that cube. I drew one too many here, really. I should have drawn them in different different colors and things. Okay, whatever. that is X, Y, and Z. And when you're rotating, it's very important to remember what axis you're rotating around. Because if you want to rotate 90 degrees around X, then that means that Y has rotated down and is now pointing in the Z direction, so that's not Z anymore. And the Z has rotated down to the Y direction, so they changed places. So now if we're going to rotate around Z, then we're going to rotate around this axis. Oh, I rotate around Y, sorry. We're rotating around X and Y. First rotate around X, then we're going to rotate around Y, then we're actually rotating around the old Z. Confusing. But that's how it is, and you can get something called a gimbal lock, which means that you are rotating in one direction and another direction, and you're going to rotate around the third one. The cube just doesn't move as you expect. It's just spins, which you might expect, but it doesn't rotate as you expect because you rotated the axes before you're rotating the last one. So to really point it out which order it's done in, the PlayStation SDK we are using, and probably the underlying PlayStation, specifies the order here. So it's the rotate ZYX, not the XYZ. And then we just need which axis we're going to rotate how much around. So 0 on that. So we're going to rotate X, rotate Y, rotate. Yeah, seems to find for me rotation. Okay, I call it rotation. There we go. I don't have a cube anymore, so I probably translated it and then rotated it away. Let's see, there I got the cube. Okay, cool. I'm going to just switch these two, because it makes a difference now if you are rotating, then you have rotated axes, and then you translate. So where would you translate before the rotation? In this case, you probably translate it over here. Then you have made a rotation, now you're translating some other way. So let's try that and just switch those around. That didn't work very well. So let's add a translation to the projection view instead of the model view. So I'm rotating the model, but I'm moving the camera back instead. And then I need to switch the sign there. Works wonderful. Let's try it again. I'm starting to wonder if that sign switch really was correct. Apparently it wasn't. Which really odd. If you have the object and you move it one way, then you have the camera, you should move it the other way. So don't understand that one. Apparently when I rotate it anything, it goes away. Okay. Yeah, that's odd. Let's try to just add in 0 here. Yeah, that didn't help. 0 there. Okay, so we have it. Then can we rotate it? Try to rotate it around X and it disappears. So that's not good. So I push it farther away because I think it's clipping. So we have the near and far plane, right? So I can't draw the near and far plane when we're looking at it, but you remember the near and far plane from the other videos, I hope. But we also have the clipping against the near plane, and I think it just clipped away the whole cube. That's what I'm thinking. So we're going to add in the rotation. Okay, it rotated at least. And it's acting strange. I have polygons clipping in and out. And I'm betting that that's a polygon that is pushed towards me through the near plane. So back to our FOV again. Okay, I draw that. So we have the FOV there, then the near plane and far plane, and in the middle here we got our cube at some point. I think when it's rotated and it points a corner at us, it shoots over the near plane. So we probably got a bigger cube than that. It's probably have a cube like that, and that will cut out in this case both this polygon and that polygon, that polygon and that polygon. So we only see the back ones. That makes sense. Let's see if we can find that here. That's probably two from the back side. That's one corner for sure. The other corners are not shown. That's the other corner. Yep. It has to be it has to be intersecting the near plane, but not clipping correctly. We can test that by pushing the cube further away from us, so it for sure shouldn't intersect the near plane. And it looks very funny. It looks wrong, and that's because of Z buffer is wrong. But it's not clipping the near plane anymore. So we need to introduce for the GPU that it calculates clipping against the near plane, and we need to figure out why it looks so odd. And why it looks so odd is because we haven't specified the Z buffer yet. So we're drawing it in X, Y, and we have Z, but we also have the Z buffer that's keeping track. We're keeping track when we draw a polygon here on where on X and Y coordinate it is, but we're not keeping track on the Z coordinate. And why did my inputs here just disappear? But we have a Z buffer, so we're not just having the output of the image. We have another image that it draws to and says like this corner is farther away than this one, and it just draws in grayscale in that other buffer, and that's how we can keep track of how far away something is and know if we are clipping it or not. And we're not using that buffer at all, so it's now drawing we can call it draw this one. It really draws two polygons here like that, but so it draws the back one first, that I can tell, and then I can't tell if it draw this one or that one. Other color could be good before this last one here, and I can see this order because this last one has overdrawn both the back one and the side one there. So we need to introduce a Z buffer to fix that, and we need to introduce it clips correctly. Let's try to get back. So, and let's add in the controls again that apparently got lost. On-screen touch controls. Odd, they just disappeared. Okay. So I said it doesn't clip correctly, so we need to introduce clipping. So let's make it clip badly. Yep, there we go. Now go into the initialize method, and we need to enable something. And then that is called, it's not called clip test. It can't be that simple. Clip test undeclared. So it's called, and I'm not sure that that's the one. It could be the one. Ah yeah, it is the one. Because now I can see looking into the cube, and the cube is clipping against the near plane. I guess it's the near plane. Looks like it. I say that worked. So let's move the cube away again. Not as far. Okay, that's great. Now we need to sort out the set buffer. And for the set buffer, we need another buffer. We have buffers allocated in video memory, so we need another one. And the depth buffer is only 2 in size, but since we are stepping from the last known address here, that's the size of the draw RAM, not the size of the depth RAM. That should be like this. So it's just the short per pixel to save memory. And then we need to use this buffer also. So we need the buffer width, and that should be, now we have allocated the buffer, but we need to enable the buffer. Depth buffer, let's see if that's the name of it. No, depth buffer test, depth test, very professional. So now our cube disappeared. We know it's drawn, so let's remove that again. It's drawn at the correct space, so it has, I did something with the buffers now, and I haven't told the PlayStation Portable what the values inside that buffer should, how we should handle them, because could be important in which direction you interpret the values in there. We need to tell it how we want to interpret it, and we need to add a depth range, and that's 64K to 0. Normally in OpenGL you have the buffer, and I'm going to draw it like this. Just doesn't make any sense, but whatever. It starts at 0 and it goes to some value depending on resolution. In this case it starts at 64K and it goes to 0 because it's an unsigned short, it's 2 bytes. So each pixels on the screen, we have the screen here and we have our pixel in the middle, it also has another buffer, the depth buffer, and it has a short 2 bytes for telling how far away it is, and it's inverted. So it goes from 64 to 0, and you can specify what range you want to use. That's if you want to draw something other thing into the scene and you don't want to overdraw the depth buffer, I guess you can modify that. But we're not going to do that, but you need to specify it. You need to specify that. I don't think that's enough. That is certainly not enough. We need to have the algorithm to tell us which point is nearer than the other one. So we need to add that, and that's mode maybe. That's greater equal or equals. It's not called mode, it's called func. Damn it, I think it's right. I think it's called func. I mean, it's still clipping against our plane here, but let's push the cube a bit back. But that clearly wasn't wrong. I mean, correct. So maybe that's the wrong. The greater or equal should be near us. That seems correct to me. Is it lesser and equal? No. Doesn't seem like we have enabled the depth buffer. We are missing an enabled function here somewhere. So we have set the buffer, and we have some scissor test, viewport. Oops, move those around. We have front-facing column display. Clearly has missed some enable. Let's try to enable it before we set those two values. No, that's not it. Okay, so could it be that we never clear out the buffer in our display function? We do clear it, so it's not that. Cleared it before even though we didn't use the buffer, but whatever. 65535, not 36. So it's 64k minus 1. And here we go. We got the cube spinning. I think it would be more fun with have a red color near us. Maybe just rotate it around. We'll have the rotation. Let's try to start with just rotating around and see if we can get another rotation of it. That's, for me, looks more interesting. I was thinking it's not degrees, I guess. Radians, I would guess. And it looks like it. So you got, you know, the degrees, 360, but the radians is 2 pi around, I guess. So you divide one by the other, you can get 57 degrees per what? Now the keys disappeared again. You get 56 per 1 radian. So radian is about, that's 4, so 56 is that size. That's about 1 radian, I guess. So yeah, so you need to convert your degrees while spinning things. So if I wanted to turn it half rotation, there we go. Red was in the background before, now red is on the front. So let's try this on the PlayStation. And it's sad that I don't have a good top down to display this, really. I'll just display it over the keyboard there. I go up to USB connect. Takes a while for Windows. Other operating systems that are better than Windows, but for now I'm using Windows, so it is what it is. So let's find our code. It's live coding. It's not live coding. It's build PSP. There we go. Bin. Just drag it. Am I in the correct folder? I'm not. Need to go into game. There we go. Just drag over that one. Place. See that it stopped blinking. I hope it transferred over before I closed the windows. And I got some memory bug. So I messed up something. And that's really good that we got that. Because that means that there is some difference between the emulator and the real PlayStation Portable. It just points that out. So I will try to debug that and get back when I figure that one out. Okay, that's amazing that it works at all. It's also not that hard to see the error, and probably some of you that was looking at the code when I coded it found the error. So you need to specify different memory areas in the PlayStation for, you have the display RAM and you just, so you have the different buffers. just in the memory. And we just going to tell it that location is 0. And then we know the size of the first buffer, and that's our display ROM. We know the size of that one, it's here. So that's our next address for our draw ROM. So this is the physical display that's going to be displayed. Here is where we draw it for the double buffering, and then we're going to swap it over when we have been drawing it. And then we need to know the size to the next address, and that's the next one there. And then we have the address to the next buffer, and that's the Z buffer for the Z values that we're going to draw the Z values into. But since we need to set up the memory ourselves on the PlayStation, I mean, this memory allocation, just put them to something, right? I, stupidly enough, put them to the same base value here. So I'm actually drawing the Z buffer here. I draw it directly over our double buffered drawing area. So first I draw in the drawing area and draw the Z buffer into the same area. And then we're swapping over to the screen. So both of the contents of these two gets swapped over to the display. And I haven't verified this, but that's what's happening. Let's see where the can I get closer up here to the camera? Is it possible? So you can probably see there's some junk on the screen, and it's junk on half of the screen also. Just reaches half the way down here, and that's not so strange, because we said that the depth buffer, the last one here, was only a short per pixel, and the colors are an int or 4 bytes. We specify down here, we specify the size of our draw buffer. That's the same as the display. So we're going to save it in 888, which is alpha and red, green, and blue, but backwards. So I guess it's red, green, and blue backwards and then alpha. So let's fix that, and I'm pretty sure it will save the day. Just offset it from correct memory address, compile it, and then we can also notice that our emulator isn't a true emulator. It doesn't emulate the video RAM of the PSP, because the emulator would also mess up. I was going to say a word there. Would mess up, but it didn't. So don't trust the emulator. Now let's quit out from this and see if we can finish this video with actually a working example. We go back to connecting. There we go. And why I'm redoing all of this all the time, copying it over, it's not like you don't know how to do that. It's just if someone hasn't looked at the other videos more or less, and since I need to copy it over anyhow, because why not record it? I can always carry it out in edit if I want to. So let's see, where is the game? It's on the memory stick. And there we go. The shadow that we had is the shadow we had over the screen is gone. So it was the Z buffer that was drawn on top of our draw buffer and then swapped over to our display. So now we have a spinning cube with the working control input on the PlayStation. So go and code PlayStation, and I will continue to, I think it's texture mapping on the PlayStation next. So see you.